Hello, this is our implementation of Cassandra, a key value store. So in this video we will show how it works using a messaging application that uses it to store key value pairs. We will then explain the source code. So as you can see, we are on OSL 25. We are going to start 3 Cassandra nodes. Unfortunately, they are on the same system. We haven't tested the system by creating nodes on different machines. It will take a bit of work. Okay, so let's start the nodes. So this is the command. The 2 arguments are the node ID and the helper ID. So the helper ID is -1 because there are no nodes yet in the system. So we start. So this is the finger table. Now we start the second node. It starts in a different directory, Cassandra 2, and so the ID is 89 and it will contact 1 to get into the network. So these are some debug messages, and we will start another node. It is started in Cassandra 3. Its ID is 259 and it will contact 89 to get into the network. We start the messaging application now. So it knows only one of the nodes, node 1 in our case. It will perform all insert and get requests by contacting node 1. We start the client now. So let's chat with another person. So the message is delivered. Key of the message is 2, which is the ID of the sender here. And keys 1 to 88 will belong to the node ID with ID 89. So let's see the messages, debug messages. So 1 receives the insert request, but it determines that the key should be on 89 and it transfers it to 89. Now this is node 89. So it inserts itself because it is the right node for the key, and then it starts replication. So replication factor is 2 in our case, and the second replica will go to the successor of this node, which is 251. So 251 receives the request for replication and it is done replicating. So for a brief moment I will describe the table structure. There are 2 tables, interaction and term, for 2 types of searches. So for a message there is exactly 1 insertion on the interaction table, and the number of insertions in the term table is equal to the number of words in the message. So 1 insertion for each word. So let's see if the messages have been stored on disk. So this is the directory for node 1, and if you go to the interaction, the place where the records for interaction table is stored, we see that node 1 is neither so we know that node 1 is neither the right node for the key, and it is nor the uh, holder of the replica, so there is nothing stored. Similarly for the term table. Now let us go to the home directory of node 2. So here also nothing is stored. So this is because we keep 3 inserts in memory, and whenever there are more than 3 inserts, we dump to disk. Now 3 is used only for demo purposes. We can in practice we can have 10,000 records, for example. So similarly for node 3, nothing is there right now. Now let's send another message to the same person from the same account. So node 1 will do nothing but transfer the request. So we can see that at some point the records were written to disk. Here also node 3 also writes to disk at some point. Now let's again see the records on disk. So for key 2 a directory has been created. Let's go. So the first message is now on the disk, and the second message is still in memory. So this is node 2's directory. Similarly, we can verify that the message has been stored on node 3 as well. So this is for the interaction table. For the term table also we can see briefly. Yeah, so 2 messages have been stored on 2 super columns, high and there. Okay, we explain some of the source code now. So this is the code for Cassandra server. So this is the replication factor. It is configurable. Let's see the insert function. So first we find the node which is the holder of the key, and let's say that node has ID coordinator. So if coordinator is not equal to my ID, then we transfer the insert request to the coordinator. So we obtain a stub here. So this is a stub, and call the insert function. Otherwise we insert it ourselves. So if the number of records in memory are already 3, then we write to disk. Otherwise we store in memory. So now after storing in memory or disk, replication is started. So if the number of the replication factor is k, then the k minus 1 replicas are stored on the k minus 1 successors of the coordinator node. So we call the replicate function on the successor node. So we first obtain the successor, we call the replicate function with the argument k minus 1, which says that k minus 1 replicas are yet to be stored. Let's see the replicate function now. So this is the replicate function. It will do a similar thing as an insert. Then after that, it will decrement the number of replicas that are left to be stored. So this is variable is decremented. Now it obtains. So if there are more replicas to be stored, this node now obtains the successor node and then calls the replicate function. Otherwise, it will just exit. Again we are back to the insert function. So this replicate will return only when all the replicas have been stored. So we are performing synchronous writes. Let's see the get function. So it is in many ways similar to the insert function. But the difference is that we just contact the coordinator node for the records and no other replica holders. And we obtain the value and then return it.